Okay, I believe we're back. I was just reorganizing here because I don't really need the paint window at the moment. So the idea I had, and I'll probably want to get my, eh, I'll just go the, um, from what I remember. So this is not something that I necessarily have any proof for whatsoever. It's just an idea I was tossing around in my head, and I have done a little bit of research into what other people have said on the matter. But this idea is so it's the idea that um, so in three-dimensional space we have momentum. So what that means is that if if I'm moving and I have mass, then I have some vector associated with that, which tells the direction and the magnitude of that of my momentum in that direction. And what momentum does is when I collide with something, then I transfer momentum, and there's always this conservation of momentum, which plays out into uh, so it the conservation of momentum means that you can't create or destroy momentum. So in a collision, uh, the the momentum is always preserved. So either I kept it or I gave it away or somewhere in between. So what I was considering is the idea of considering time as a fourth dimensional space dimension. So now this is not a new idea. So time, whenever people are talking about space time, then they are talking about uh, time as a fourth dimension. And so whenever people consider a trying to visualize a fourth dimensional uh, a system, it's nice to think of time as a fourth dimension because you can think of it as a spatial dimension. Because if you think about where we are in time, and actually the program just replaced, and so it didn't kick in the optimizer, which is a little disappointing, but it just means that the program is learning, so that's not a problem. So if you think about time, and so where we are in time right now, you can be somewhere with the exact x, y, and z coordinates in this moment in time that someone else was in a different moment of time. So it's almost as if there's another axis for where it locating something and for identifying it. So you can set so it'd be like an x, y, z, and then I don't know a t, but probably not t. Um, in terms of a coordinate. And so what I was considering was the idea of there being momentum through time, because obviously we're moving through time in what seems to be a constant rate. Um, so at least our experience of time is constant, and so when we consider time, we it could the idea isn't too crazy to think of there being a vector with our momentum and there being a slight um, lift into the time axis, because that means that we are moving forward in time, or at least what we consider forward. Um, so, what is interesting is when you consider a sort of time component to this momentum, then you can start to visualize the effects of large forces and why time is dilated in those forces. So what happens is, and so this is all stuff that this is all ideas that I've speculated and then went and tried to research. This is not necessarily me saying exactly what's happening. This is just what I was tossing around. So what I was considering was the idea that since gravity is a radial force and it creates a field in all directions, that it would also create a field in in the time direction. And so what that would mean is that if you had a force in the time direction, then it could actually change that vector to be moving faster or slower through time. And so what happens is when you have a inward force, you get a arc, and with that arc, there is a acceleration, but it is a orthogonal acceleration, or at least part of the component is orthogonal. The normal acceleration is orthogonal. So that acceleration changes the direction of a vector. And if we're talking about this four-dimensional space-time in terms of a coordinate system, then actually it may be easier just to consider 3 dimensions and just consider our space two-dimensional. So if we just think of a flat surface with an x and y, then time can be the vertical axis, but that still doesn't necessarily allow you to visualize it as much. But so what I was saying is that if you have a vector moving through this field, then it could pull that vector, it could shift the direction of that vector, so of that velocity, so that it is moving at a different rate through time. And the interesting idea is that in terms of large gravitational fields, and even our gravitational field for that matter, is that we see a time dilation through that field. So, and so this is all based off of this whole concept is basically around the ideas that were put out by Einstein and later touched upon by other physicists. But what is interesting is that it kind of coincides with this idea of there being this total momentum through time and through time and space. So what I got, and I may be completely wrong, so I challenge you to correct me in the comments and whatnot if I am wrong. What I was getting was that we have a constant velocity necessarily through time, through time space, and so when we hit something that changes the direction of that, the magnitude of our velocity doesn't change, but the direction of it does into this fourth dimensional idea of a time axis. And so that's what was intriguing to me, was that large forces can actually alter the object's experience of time. And so we have seen that with particles that are decaying, that would normally have decayed in a short amount of time. If they're moving really fast, then that's not necessarily a large force, but I also had some ideas on that. But so it's the idea of time dilation in a large field. So this isn't restricted just to gravitational fields. It also applies to large electrostatic fields. And so there is a time dilation that could be associated with an object being in a large electrostatic field. And that got me thinking that if one could create a capacitor that could create such an intense field of electrostatic force, then then you could induce a time dilation in an object, for instance, and then so the side of it that I didn't necessarily get an answer for, and what I was considering was that um, when you induce a time dilation, it's a change in momentum. So if even if there is some resistance to that, to going a different pace through time, or through to going a different magnitude of the time component for that vector, if there's some resistance that forces it back to what we consider normal at the moment, then it I in my eyes it wouldn't be instantaneous. So that may be completely wrong, and I'm not completely sure about that. But in terms of normal momentum, so let's say we have an object flying through the air, then it will go. It will stay at that speed until the air slows it down. And so what I was considering was the idea that if something is moving faster through time and something else were to collide with it, or at least try to occupy the same space as it, then it could technically collide in the time axis with that object and push it and dilate its experience of time. So that was the idea that I was tossing around, because that would basically be time travel, but it wouldn't necessarily be practical, because you'd be being hit by this massive force to knock you forward. Um, so and that would require also a immense amount of power to create that such a field in a capacitor. Um, Either that, or you would have to uh, make the particle that you were working on extremely small so that it could fit in a extremely tight capacitor that would create a larger field. Um, but so that was the idea, and if you have any answers or comments on that, I would be very open to hearing them, because I wanted to I just wanted to get get my head around the idea of whether or not something could necessarily be whether a particle that is being that is having its time dilated could technically collide and transfer that momentum in the time axis to another particle. So I know that's quite a mouthful. Like I said, this is all uh, late night, kind of just staring at a notebook paper and writing everything I was thinking down deal. So I understand if this wasn't necessarily what you were looking for when you turned on the video, but um, this was just something I had in my head, so I wanted to get it out. I wrote it down, and then what actually happened was I wrote down everything I was thinking, and then I researched and found out that most of what I was thinking was already something that was a basis in upper level physics classes, and the rest of it was wrong. um, so uh, the idea of there being a momentum is true, and we see that with particles moving through space and whatnot at high speeds, because they are affected by these relativistic effects. And I talked about relativity in a previous video. Um, so the equations that you use to calculate that do encompass time as a factor. But my idea, and it may be a little science fictiony, was the idea to induce that so that you could technically force something forward in time without the field itself. But then at that point, you might as well just force it through time with the field. So I'm not really sure about that. But that was just the idea I was tossing around. So I wanted to let you guys know about that, or at least get get it off my chest. But other than that, I don't really have too much more to talk about on the topic. I'll check to see if there are any comments. And so I believe I will move on to my next section, which is the normal section where I draw something on paint based off of random numbers. So I will be right back.